So now let's see number 22. We have to find the equation for the planes that is that will pass through this point 1, -1, and 3, and it will be parallel to this equation, right? So every equation they represent some 2D or 3D objects, okay, or some motion. So okay, so if you look here, can you tell me where is the direction and where is the intercepts? Like you can say here this is our vector, right? Because we have some kind of line. So here we will find the vector. So the vector will be 3 plus 1 and plus 1, right? So the non-vector will be 3, 1, 1. So 3 is A and 1 is B and C is the value of C. Okay. And then okay. Right. And then x0, y0, and z0, they will be our point or the intercept. So here our point is 1, -1, and 3, right? So 1, -1, and 3, they will be our x0, y0, and z0. So now we just substitute the value here. Like this was our general formula. If you look here, this was our point normal form, or the point norm equation. So again, we just use the same way before. We substitute the value, and here is the answer. Okay, here is the answer. So this way we define a plane in the in the space, like where it is going to, where is the direction of this plane, and like how it looks like. Okay, all those things. Maybe we will learn this in our, maybe we will apply this in our programming knowledge, or maybe during our mathematical modeling. Okay, so I don't know where is the application right now, but there is a lot of application of this topic. So now let's see. Instructions. Distance from the point in the plane. Okay. So now we have to calculate the distance from the point in a plane. So here is a point, right? Here is a point P. We have to find the distance from this point to this line. Okay. We have to find the distance from this point to this line. So the answer will be, the distance will be, so firstly we need to find PS, or we need to find the direction. Okay, so we need to find the direction first, and then we multiply the direction with the v vector, and then we divide by the norm of v. So here S is the point out of the line. So okay, and then P is any point on the line. Okay, so our line is here. Let me use another color. Our line is here. Okay, our line is here. So this P point is on the line, and at the first sign, this S was out of. Okay, let me draw the line again. So this was our line, and at the first sign, at the first stage, this point is, it was out of this line, right? This point is out of this line. So that's why our Laoshi has written here like P is any point on the line, and S is the point outside of the line, and then V is the direction. V is the direction of the line. Okay. So okay, fine. Now let's see how we calculate let's see a real problem. Number 33, but maybe it is not 33, it is going to be okay, 33. Yeah, so here if you look here, find the distance from the point to the line. That means we have a point here, we have to find the distance, and we have a line here, so we have to find the distance from this point to this line. Okay, we have to find the distance. So our point is here 0 0 12, and then our okay, and then our line is on first line, second line, and third line. Okay, oh yeah, this is a parametric equation. If you see here, all of them are dependent on t, right? So this is a parametric equation. And so okay, so we firstly find ps. Do you still remember ps? This one, ps. Okay, so ps means, so here p is our point, and s is a point outside of the line. So but if you look here, we here on we have given only one point, right? Here only one point is given, 0 0 12. So okay, so I have written here that point is outside of the line. Okay, that point is s, that point is s. Okay, and then another point, if there is no other point, you have to think like this point is the origin. Okay, this point is the origin. Do you know the origin is 0 0 0, right? So now if you try to find ps, so do you still remember how do we find ps? We just substitute, sorry, so we just subtract s from p, right? So 0 minus 0 minus 0, and then we subtract p from s, right? We subtract p from s. So here is if you look here, here is s and here is p. So we subtract p from s. Okay, that means it will be something like s minus p. If you want to like remember, it will be something like s minus p. Okay, so s minus p, that is 0 minus 0, that is 0, and 0 minus 0, that is also 0, and 12 minus 0, that will be 12. So that's why I have written here 0 0 12. Okay, and then we need to find the we need to multiply with the norm vector, right? So if you see here, our norm vector here is if you just take the coefficient of the variable, that is going to be 4 and minus 2 and 2, right? So that's why I have taken here 4 minus 2 and 2. Okay, this is the v vector, or this is the norm vector. And then if you calculate, if you just calculate if you just do the expansion, so you will find the result. Okay, I think maybe you can find this. Can you? I already discussed how we find the cross product. So that way you have to find uh, you have to calculate this part. Let's should I explain again?
No, I get it.
Okay, okay.
I know that.
And then you just take the coefficient. Okay, so here's the result. Here's the result of ps cross v. So you see here, ps cross v, the result is here. So this value and this value, they are same. Okay, and there's she has just written a simpler way. Okay, so nothing fancy here. Oh, okay, so if you look here, here is the norm value, right? So you just need to add them and square them and find the square root, right? So this is the result. Okay, uh, this is the norm value of this cross product. I think you can find this, right? Can you, Grace? Okay, fine. And then norm of V, that is very simple, like 4 square plus 2 square plus 2 square. So it is going to be root over 16 plus 4 plus 4. So the final answer is 2 root over 30. Okay. So if you don't want to waste your time, you can just keep this part. This is the answer, okay? And if you have time, you can explain. You can just write down the simpler form. Now let's see number 32. 32, where is that? Okay. So 32, we have to find a plane through the points P1 and P2, and perpendicular to the plane, this plane, okay? So here our plane is intercepting 2 points, right? One point here, another point here. And then it is also, and it is perpendicular to the plane, this plane, okay? So perpendicular means it is at the 90-degree angle, okay? So, okay, let me see. Perpendicular. So at an angle of 90 degree to another line or surface, it is called perpendicular, right? So if you see here, this line and this line, they are perpendicular, right? Because they are at 90 degree angle. So, okay. So this is the question. And now let's see the answer. So distance from the point to the plane, we know this is the general formula. Okay, this is the general form: x plus by plus cz plus d equal to 0. I mean, this is the same as before, but this is another style. Okay, another style. So the distance from, so here we have given 2 points, right? P1 and P2. So the we have to find the plane through the points and perpendicular to the plane. This. So now their distance, I mean the distance from the point to the plane. Number 32. So distance from the point to the plane. I mean, here is a point, and if here is a plane, so maybe, yeah, distance from the point to the plane. So their distance, okay, their distance, it is denoted as d. So d is equal to the norm of this vector, okay? So here we can see like okay, so number 32, this is not so now she didn't explain number 32 very well, so I will go back to the solution, okay? So this is maybe going to be number, it is 12 point, it is 12.5, right? 12.5. Yeah, so number 32. Okay, so here, okay, here, look here. So we had two point. So here's number 32. So one was P1 and another one was P2. So now we need to find the direction, or we need to find the value of I mean ABC, okay? So we need to find the direction. So P1 and P2. So do you know how to calculate P1 minus P1 P2? I already discussed in. I have already talked about this. So P1 P2. So if you look here, okay, 2 0 minus 2. Okay. What is the question? Okay, here. So we are trying to find P1 P2, right? P1 P2. Okay, P1 P2 vector. So you already know that we just need to subtract P2 minus P1. So 3 minus 1, that is going to be 2. So I write down here 2, and then 2 minus 2, that is going to be 0, and then 1 minus 3, that is going to be minus 2. So 2 0 minus 2. you see here 2, 0, minus 2. Okay, and then this norm is here. Okay, this norm is 4, minus 1, 2. So you see this norm is here 4, minus 1, and 2. So the coefficient of that I mean coefficient of that vector, or the coefficient of the line that is perpendicular to our main our new line. So this way we find the norm, and we find the I mean P on P2, right? P on P2 vector. So I mean the direction of that vector. So then we just do the cross multiplication. So the result is minus 2i minus 12z minus 2k. So minus 2 is A, and minus 12 is B, and C is minus 2 is C. Okay, and then there is a point given, right? 1, 2, 3. So 1 is x naught, and 2 is y naught, and 3 is z naught. Okay, guys. So now you already know all those points, and so now you just need to substitute the value, right? So the point on the plane. So the point on the plane, it will be a into x minus x naught plus b into y minus y naught plus c into z minus z naught is equal 0. Okay. So now if you calculate, it will be x plus 6y plus z equals 16. So Grace, can you understand now?
Yes, Omar, I get it.
Okay. Now let's go to the next question. We have linear algebra examination next week, right? So I have to arrange another group study tomorrow. I mean, I have to revise all those things of linear algebra within on days, and I have 3 tuition tomorrow. I have on in the morning, another in the noon, and another at night. So, and Ramadan is okay. So it is very tough for me to manage all those things.
You're so kind, Omar.
I mean, I have to study all the day and all the night. I mean, that's very tough.
The more you study, the more you're smart.
Yeah, maybe. I also need to rest my brain, because
I see.
Yeah, that's also important. Okay, so let's continue. I'll try to give up all those tuitions, and I will only keep on tuition because because their examination is very near. So I need somehow I need to give time to them because their high school exam is very near. I mean, after on month, they will sit for high school examination. So that's why I was quite busy there. So now let's continue to the next question. Number 39. Okay, 39. So find the distance from the point to the plane. Okay. Find the distance from the point to the plane. Here point is 2 minus 3, 4, and the plane is x plus 2y plus 2z equal 13. So you have to just think another way, like this plane, it tells something, okay? It tells a point. Like if you're, okay, so if you have a point here, and you have to find the distance from this point to a plane, and then this plane has 13, right, on the right side. So it means that there is another point here that is going to be that is also going to intercept that line. Okay, so if I explain here, you see like our point, the first point is 2 minus 3 and 4. Okay, so this point is given here, 2 minus 3, 4, and second, and do you remember this formula, ax plus by plus cz equal plus d equals 0? So according to this formula, this 13 or if I just take 13 on the left side, so I will get a homogeneous equation, right? Do you know what is homogeneous equation? Homogeneous equation is the equation that on the right side we have only 0. So if at the right side we have only 0, that is called a homogeneous equation. So here we try to make some kind of a homogeneous equation, and this minus 13, this is the value of d. And then I have just written here x is 2 and y is 3, y is minus 3 and z is 4. Here d is minus 13. I have just written all those values here, okay? So that I can just plug the value in the equation, I mean in the formula, and we can calculate the result. So here the result is 3. So this way we find the distance from the point to the plane, okay? So here a point is given and also a equation for the plane is given. Grace, can you understand?
Yes, Amar, get it.
Okay. So now let's see 48. Angles between the planes. Yeah, okay, so now we have to find the angles between the planes. So maybe here is a plane and here is a plane. So there is angle, right? So we have to find the angle between the planes. So here is 5x plus y minus z equal 10. Here is a plane, and x minus 2y plus 3z equal to minus 1. Here is another plane. So to find the angle between those two planes, we just need to find the norm value. So norm value means their coefficient of x, coefficient of y, and coefficient of z. So 5 plus 1 and minus 1. So here is 5 plus 1 minus 1, and the norm 2, it will be 1, then minus 2, and then 3, okay? So 1, minus 2, and 3. So the angle will be cos theta, okay? Cos theta. So it will be the dot product of those norms and then the norm value of those dots, of those vectors. So the dot product will be 5 multiply 1, that is going to be 5, and then 1 multiply minus 2, that is going to be minus 2, and then minus 1 multiply 3, that is going to be minus 3. And then down here, norm of n will be 27, and norm of n2 will be, n2 vector will be 14. So we get like, if we calculate, we will find like 0, right? Minus 2 minus 3, that is going to be minus 5. So 5 minus 5 is 0. So 0 by something is equal 0. So now you have to see, like, you need to, you see that cos theta is equal 0, right? So you have to think for which value of theta, that is which value of cos theta that is 0. So we know that cos 90 equals 0, right? Cos 90 equals 0. Or so you can just memorize those two things, like sine and sine. Okay, so sine 0, 30, 45, 60, and 90. So sine 0 is 0, sine 30 is half, sine 45 is on by root 2, or somewhere you can just say root 2 by 2, okay, the same thing. And sine 60 is root 3 by 2, and sine 90 is 1, okay. And the value of cos, it will be opposite direction to sine, okay. I mean cos 0 will be 1, cos 30 will be root 3 by 2, so cos 45 will be 1 by root 2, and cos 60 will be half, and cos 90 will be 0. So you see here cos 90 is 0, right? So here is cos 90. So you have to memorize the value of sine, okay? Then you can easily tell, like, what is the angle of cos theta is equal to 0. So cos 90 is equal to 0, okay? or there is, you can use your calculator, like you see here cos theta equals 0. So if you keep theta on the left side and if you take cos on the right side, so it will become arc cos, right? If you take cos from left to right, so cos will be arc cos. If plus becomes minus, so cos becomes arc cos. So arc cos 0 in your calculator, it will show you 90 degree. Okay. So this way, if you find the angle between between two planes. Okay, yes, can you understand?
Yes, Amar, I get it.
Okay. So now we are homework 3. We are in homework 3. So homework 3. I think I can. Okay. Homework 3. So firstly, we need to find the second order differential equation. We need to see what is second order differential equation. So you see here we have two derivative sign, right? And we have 0 on the right side. So if we have 0 on the right side, that is called homogeneous. And if the highest the highest differential highest derivative, okay, the highest derivative, that is our order. So here our highest derivative is 2. So for this equation, it is a second order differential equation, okay, because the highest order is 2 here, or the highest derivative sign is the second derivative. So here a must not be equal to 0, okay, because if a equal to 0, then this whole part it becomes 0. So here a must not equal to 0. So now we can write down this part into some kind of simpler form, okay. So we can write down y double prime as r square, and we can write down y prime as r, and we can just skip this y, okay. So we can write down c. So this is the standard form, or this is the standard form how we write down a second order homogeneous differential equation. So now the general solution is y equal to c on into e to the power r on x. So here r1 and r2, they are the solution, okay. So if we just calculate this part, we will get some solution like r1 and r2. So those solutions we have to write down here, okay. And then, okay, so this is the formula. Y is equal to c on, this is the general solution. Y equal to c on into e to the power r on x plus c2 into e to the power r2x. So now, if r1 equal to r2, then the general solution will be y equal to c1 into e to the power r on x plus c2 into, the change is here, okay, the same as before, but the extra part is here, x into e to the power r on x, if r1 is equal to r2. So now let's see how we can calculate those. The first question here, 17.1. Okay. So find the general solution for the given equation. Here is y double prime minus the first one, y double prime minus y prime minus 12y is equal to 0. So if you look here, we can just write down y double prime as r squared, right? And then minus y prime is as minus r, and then we have 12y, so we can just skip this y, so we can write down minus 12 equals 0. So if you do factor factor decomposition, it will be decomposition. Factor decomposition, right? So I have written the wrong spelling. Decomposition, okay. So if you do the factor decomposition, you will get something like r minus 4 into r minus 3 equals 0. So here r1 will be 4 and r2 will be minus 3. So can you do factor decomposition, Grace? Do you know how to do factor decomposition?
Yes, Amar. I know.
Okay, I will also show another way. So you can just do your own way, okay? You don't need to get into this.
Okay, I get it.
Okay. I'm drinking some water. বাহ, একটু আস্তে কথা বলি, ক্লাস নিস তো। আচ্ছা, ঠিক আছে। So let's start from. Okay. So now we see like we have got R1 and R2, right? And then we have to substitute those value here in the in the in the general solution, okay? In the formula. So here is R1 4 and here is R2 minus 3. So this is the answer. So the third question the same as before. The fifth question same as before. The seventh question same as before. Okay. So there is nothing fancy here. The question number 9 same as before. Okay, yes, I think you can understand. So can we move forward to this question? Hello. Find particular solution.
Sorry, what, Amar?
So from number 5, 6, 7, they are same as before. So I have skipped those. Okay. I think
You can skip. You can skip those number.
So let's go to the 31st problem. Find particular solution. So now we have to find the unique solution or the particular solution of the second order initial value problem. So 31 we have y double prime plus 6y prime plus 5y is equal 0, where there is two condition given. Okay, first condition is y of 0 will be 0, and then the second condition is derivative of y of 0 is 3. So okay, so now the same as before. Now we need to find the unique solution or the particular solution. So do the same as before, like factor decomposition. So we get our general equation here, and then you have to look at the condition. Okay, so here is the condition: y0 equals y0 equals 0, and y prime 0 equals minus y prime 0 equals 3. So I have written the conditions here. Now just see here. So the first condition, y of 0 equal to 0, right? So that means here in the value of y we will write down 0. Okay, and then the coefficient of e, that is c1, and coefficient so here it is c1 and c2, right? So we are just going to take the constant out. Okay, so we got c1 plus c2, and our condition tells like it will be okay. So let me explain a little bit here. Y of 0 equals 0, right? So if you substitute the value here, okay, x equals 0, because this y of 0 means what? Y of x, right? Y of 0 means y of x. So you have to put 0 in the here, right? Because it tells you y of 0. So the value of x will be 0. So minus 5 multiply 0, that will be 0, right? So e to the power 0, e to the power 0 is 1. So that's why I have written here C1. And then if you substitute the value here, x equals 0, so e to the power, again e to the power 0, so e to the power 0 equal to 1. So this part we can just cancel out, so this is C2. So that's why I have written here C1 plus C2 equal to 0, okay? Grace, can you understand?
Yes, Amar.
Okay, so now there is y prime 0 is equal to 3. So you have to find the derivative of this general equation. Okay, so now let's find the derivative here. Derivative of e to the power minus 5x. So it is some kind of I mean, you have to use chain rule here. Okay, so chain rule means outside inside rule. So here, if we or you can just use like u substitution, right? Chain rule and u substitution, they are same. So minus 5x, we can let minus 5x equal to u. So derivative of e to the power minus 5x, it will be, you just let u is equal to minus 5x. So e to the power u, and then for chain rule, we know that outside inside rule. So this is our inside, this is our outside, and multiply inside, we have minus 5x, right? So derivative of minus 5x, it will be minus 5. Okay, do you remember derivative of minus 5x? It is minus 5 from the formula n x to the power n minus 1, nx to the power n minus 1. So from this formula, you can say like derivative of minus 5x is minus 5, and we use the chain rule here, or the u substitution rule here. So we get minus 5 into, okay, we get here minus 5 into e to the power u, or minus 5 into e to the power minus 5x. So that's why I have written here minus 5 into e to the power minus 5x. Okay, it is just the simple differential calculus. And then e to the power minus x, it will be minus 1 c2 into e to the power minus x. Okay, so this line here, it is y prime. And now if you look here, now if you look the condition, if you look at the condition here, so the condition is y prime equal to y prime 0 equal 3, right? So that means you have to write down 3 on the left side, and then you have to input x equal to 0, right? So if x equal to 0, then this part, it will become 1. So we can just skip this part. So if x equal to 0, this part becomes 1, we can skip this part. So we get minus 5 into c1, then minus c2. Minus c2 is equal to 3. Okay. Grace, do you understand? How do I calculate this?
Yes, Amar, I get it.
Okay. So now, just do the calculation. Okay, like you just take c1 on the left side. Okay, so you just take c2 on the left side, and you will find c1 is equal to minus c2, and then okay, I mean, you can do another thing. You can just let there are two equations. So if you add those equations, you can cancel out c2. So you get minus 4 into c1, minus 4 into c1 equal to 3. So c1 will be 3 by minus 4. Okay, so these are simple calculation. I think you can find c1 and c2. Can you? If I let should I explain? Should I explain?
No. I do understand.
Yeah, fine.
I know that.
So this is equation 1, this is equation 2. So you can just add them, and you can cancel out c2, and maybe here is c1 plus C1 minus 5 C1, that is going to be minus 4 C1. So is equal to 3. So if you take 4 on the left side, so you get C1 is equal to 3 by minus 4. This way you calculate also C2. So I think that's pretty simple for you. So now we just need to substitute the value of C1 and C2 because this is the particular solution. So this is our general solution. So here you need to substitute the C1 and C2. Okay. So it will be minus 3 by 4 e to the power minus 5x plus 3 by 4 e to the power minus 6. Okay. You substitute this C1 and C2 here in the general equation. So Reda helped us to understand this part back in maybe on month ago. So now let's continue to the next 34. Let me drink some more water. Okay, so here we need to find the same thing, like find the unique solution of the second order initial value problem. So the same thing, okay? Just write down this equation, compare the condition, and then find C1 and C2 and substitute those values in the general form. So I think that's also pretty simple for you. We can skip this part. And then exercise 17.2, we have 17.2. Okay. So now we have to calculate non-homogeneous linear equation, okay? Or I mean non-homogeneous second order differential equation. So Grace, are you there?
Yeah, Omar.
Okay, fine. So now we are going to find non-homogeneous second order differential equation, okay? So
Okay.
so here is two part. First one is the general solution, and second one is the first part is the general part, and second part is the particular part. Okay, the general solution and the particular solution. So YG is called the general solution for the homogeneous equation for the homogeneous part. Okay, so YG is called the general solution for the homogeneous part, and YP is called the particular solution for the non-homogeneous part. Okay, so one part is for homogeneous part and another part is for non-homogeneous part. So first one is to find the um, general solution for homogeneous part, and the second step is to find the particular solution for the non-homogeneous part. So to find this, we do the same step as before, like the first step, like we have the equation here that is where is that? This is number one. Okay. Number one. But where? Oh yeah, here 17.2. So y double prime minus 3 y prime minus 10 y equal to minus 3. Yeah, right. Y double prime minus 3 y prime minus 10 y. Okay, fine. So this equation, okay, so you see here on the right side we don't have 0, we have minus 3. So this is called a non-homogeneous part, and on the left part, this part is homogeneous part. So we just calculate the same way before. Okay, we let y double prime is equal to r square, and then y prime is equal r, y prime is equal r, and we just omit this this y. So if I solve this, I can get r1 and r2. Then I substitute. Then I get the general solution. Okay. So after this, here is the non-homogeneous part. So if you just omit the derivative sign, then you will get Okay, just let me show you another file. Okay, let me see another file. Just a second. Non-homogeneous second order differential equation. We choose y because it's so c and then double prime equals 0, prime equals 3, and then double prime equals 0 particle for the particle solution. And to find the c and d, we back substitute into the form 0 minus 5 c equal coefficients obtain 6c. Okay, 0 minus 5c r square 5c. Okay, so let me see how can we solve this. So for non-homogeneous part, we have to just omit the derivative sign. Okay, so y double prime minus 3y prime. So on the right side, we have minus 10y and minus 3, right? I mean on the right side means just we if we omit this derivative sign, are you there? Uh, okay, so in the normal, are you back again, bro? In the normal, are you back, bro? Can you hear me? We were just talking about the second order non-homogeneous differential equation. But when did you join, bro? We are almost at the end of our meeting. Hello. Okay, so let's continue. So we have without this derivative sign, we have minus 10y and minus 3. So here, if you just let y, this particular solution is a. So we already got our general solution. So now we have to let the particular solution is a, and then this part minus 10y. So we can just let it as we can let it as minus 10a. Okay, and then we have minus 3 on the right side. So if I just take this, if I just take this minus 10 on the right side, so I will get a is equal to 3 by 10. Okay, so then I need to substitute the value of a y equal to c1. So I have to substitute the value of a on the on the on the general solution. Okay, here. So just add plus 10 by 3. Okay, just add plus, sorry, 3 by 10. Just add here 3 by 10. Okay, 3 by 10. So this is the solution for for second order different homogeneous differential equation. So firstly we found the general solution, and then we tried to work with the non-homogeneous part. So we got our a is equal 3 by 10, and then we substitute the value in the general equation. So this is the final answer. So for the next question here, the second question, y double prime minus 3y prime minus 10y is equal to x minus 3. So okay, so let's work on this problem. If you look here, the non-homogeneous part, this is the homogeneous part, this is y double prime minus 3y prime minus 10y. So first we need to solve this homogeneous part. So I already discussed how we can solve this part. So this is our this is our homogeneous part. And now okay, so insert into y double prime minus 3y prime minus 10y equals to 0 minus a. So this part, okay, so this part was our homogeneous part and this part was our non-homogeneous part. So if I calculate this if I let this non-homogeneous part as like 2, we can let 2 is equal to a, and then we have x. Okay, so we have here in a non-homogeneous part we have 2x minus 3. So if I let 2 is equal to a, and then we have and if I let 3 equal b, so I will get, so here I will get ax plus b. Okay, I will get ax plus b, and then minus 3a minus 10, and then I let y prime is equal a. Okay, so minus 3 into a, and then I let oh sorry, y prime equal y double prime equal to a, so minus 3. Okay, I have another solution here. I can just explain from that part. Y g of x equal to x plus 3. Particular solution is x plus t. So y particular solution yp prime equals c. Y double prime equals 0 where c and t is constant. So bro, anyways, I have to review this part because I saw another solution, but I have to review like how our Laoshi explained here. Okay, so I think I will explain this part later. Okay, this part, I mean the second question of second order non-homogeneous differential equation. So I'm pretty confused here, like how these things was transferred into, or I mean how non-homogeneous part was calculated. So I need to research a little bit on this topic. Minus 3a minus 10 x plus b equal to 2x minus 3. So minus 3 x plus b. Y means a, so minus 3a minus 10 into x plus b. Y prime is called 3, okay, but this 10 y equals 2x minus 3 minus a. If I differentiate, so it will be minus 3, and then double prime. So where is y? Y is minus 3. So if I double prime this part, so y prime is equal y to the power on minus y to the 0 equal to 1. So yeah, on prime. Okay, so I got it. So the thing is here, you just need to you just need to calculate this part separately. Okay, so 3y prime, if you still remember those differential equation part, so 3y prime, it will be okay. So okay, 3 in minus 3 into y prime. So y prime is equal to, so minus 3 into y. We know that y prime means y to the 1 into y to the power on minus 1. So y to the power on minus 1 means y to the power 0. So minus 3 into y to the power 0. So y to the power 0 is 1. So the ultimately the result is minus 3. So that's why I write down here minus 3. Okay. And then if I calculate here, okay, y double prime. So y double prime is equal 0. Okay, let me show you. Because y double prime is equal 0 means y prime. So we have to firstly find the y prime, and then we have to differentiate again. Double prime means first we have to differentiate y, then we have to differentiate the result again. Okay, so let's find y prime. It is going to be y to the power 1 minus 1. So that means y to the power 0. So y to the power 0 means 1, right? So here I can write down 1. And then the result. So I have to differentiate the result again. So derivative of 1, that is 0, right? Or derivative of any constant, that is 0. So that's why y double prime is equal to 0. Okay. So I have written here, you see y double prime is equal to 0. So I don't write down anything for y double prime. I just write down minus 3y prime. So for minus 3y prime, it will be minus 3a. And then minus 10y. So I can let y is equal 2x minus 3. Okay, because here for with minus 10y we don't have any derivative sign, and also with this 2x minus 3 we don't have any derivative sign here. So we can write down this way, like 2x minus 3, we can let x equal to we can let 2 is equal to a. Okay, we can let 2 is equal to a. So a into x, and we can let 3 equal to b. So ax plus b, right? So some kind of ax plus b. So that's why I have written 10 into x plus b is equal to 2x minus 3. So next we just multiply, and then this is just then if I calculate here, minus 10 is equal to 2. So if I take the coefficient of x, so here the coefficient of x is 2, and here the coefficient of x is minus 10. So it will be minus 10 is equal to 2. And then if I take the coefficient, if I take the remaining part, that is minus 3a and minus 10b, it is equal to minus 3. So I have written here. So now if I just solve this two equation, I will get a is equal to minus 1 by 5 and b is equal to 9 by 25. So this way we find the value of a and b, and then we just write down this a and b here after the general form. Okay, so this is the answer for the second question. So it was the second order non-homogeneous differential equation. So okay, so this is the answer. Okay, we just write down the value of a and b here, but in the form of ax plus b. So value of a is minus 1 by 5. Value of a is minus 1 by 5, and b is 9 by 5. Okay, you see here, a is minus 1 by 5, and b is 9 by 25. So we let that this form was x plus b form, right? So I have to write down this way, minus 1 by 5 x plus 9 by 25. So you see, oh sorry, minus, because why minus? It will be minus. Okay, maybe my calculation, maybe I had written the wrong part. So it will be minus 9 by 25. So minus 5 by minus 1 by 5 by minus 1 by 5x minus 9 by 25. So this is the solution, and this is the part for non-homogeneous part, and this is the part for homogeneous part. Okay, so this is the solution, and the number 3, that is also the same. I mean, you have to just research a little bit. So for homework 2, linear first order differential equation. So still now, so for now we talked about the second order differential equation, but for homework 2 we only work on the first order differential equation. So the general form is this way: y is equal e to the power integration of p of x dx into integration of q of x into e to the power integration of minus p of x dx plus c. So we have to calculate the value part by part, okay? Part 1, part 2, and part 3. And this is the form of the equation. So here is p of x and here is q of x. You just need to substitute the value here, okay? So here is p of x and here is q of x, okay? Here is q of x. So I think you can understand by your own, like maybe I don't have some time today. I have only 1 minute remaining. So if you just convert some equation to this form, dy by dx equal pxy plus qx, and then you come here and just uh, try to find what is px and what is qx, and then substitute this value in here in the general form, in general form. So here is qx, here is px, and here is qx. So you just substitute those value here, and you if you do the integration part, so you will find the solution, okay? And then just use the condition and you will get some value for c1. So this solution is the general solution, and this solution is the particular solution, okay, for c1. So this way you take preparation for the higher mathematics, advanced mathematics final exam. I think the question will be very similar to these homeworks.